All right. So rolling a die, and this isn't it. I know this is not part of your notes, and I just want you guys to focus in here just so I can explain what I'm going to introduce to you today. So rolling a die, and somebody just chime in here for me. If I roll a die, what have we always said is the probability of just rolling a 6 on a die? Rolling a 6 on a die. What are my chances of rolling a 6? Okay.
1
Out of?
6.
So 1 out of 6 chance, right, guys? It's a 1 out of 6 chance. Most of you guys did a nice job on that assignment yesterday. It's a 1 out of 6 chance. Okay, I'm going to do a little experiment with you now. All right, in your chat, I'm going to put a website I'd like you to go to real quick, and you're going to roll a die yourself for me. All right, and then back in the chat, I want you to tell me what number came up. Okay, so just so you know, you're going to go to a screen that looks like this. Make sure you roll 1 die. All right, just roll it, and then whatever it comes up, type it in the chat for me. All right, and I'm going to record everyone's roll. All right, so here you go. So go ahead, go to the sim. Make sure you only roll 1 die. I think it's already defaulted to 2 dice. So just roll 1 die. And then do me a favor and put your results in the chat for me. And I'm just going to record it. You guys are going quick. 6, 2, 3, 4, 1, 5, 2, 6. We all good here? I'll wait a couple more seconds. There we go. Just one roll. Just one roll. That's all I need. One roll. Okay, I think I got everybody here. I got enough here. Okay, so what I'm going to do right now on my end here is I'm just going to record the results, and we're going to talk about what's the probability of rolling a 6 now based on your rolls. So let's see here. I had a 2. Just give me a time here to tally them all. All right, so here we go. Now I'm going to ask you guys, using my table, what's the probability we roll a 6 now using the results from the table now? The results from our little experiment here. Well, there was 3 people who rolled a 6 out of, let's see, how many total do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 3 out of 14 now. Do you see it's a different probability than what I asked at the beginning of just a regular 6-sided die and what you would expect the chances to be? These are 2 different kinds of probabilities I'm going to talk about today. The one we did as an experiment, the one we did as a class, that's what we refer to as, this is called an experimental probability. A probability based on an experiment, or a table in this case. Right? This is called experimental probability. You get the probability based off of the results from an experiment. Now go back to my 1 out of 6 that I asked for you guys at the beginning of class. This is what we expect. This is what we expect. We expect the probability to be 1 out of 6. This is what we refer to as the theoretical probability. All right, that's what we expect to happen. So theoretical, what should happen? What should happen is going to be our theoretical probability. Experimental is based off a table from an experiment. Okay, so I just wanted to introduce those 2 terms to you and what it means, because I'm going to ask for 2 different types of probability through the course of today's notes. Anybody want to chime in now, ask any questions before I start asking you more questions? So again, theoretical is basic. What should happen here? We should have a 1 out of 6 chance. Oh, experimental though, based on what the experiment was, 3 out of 14. All right, so let's go to our first experimental one for today, the movie theater. So notice as you guys keep reading, it says find the experimental. So that tells me, hey, use the data to find this probability. Use the data. All right, if they're asking me for experimental, use the data. What's the probability you get someone older than 12 but younger than 46? Younger than 12, older than 46. So I'm going to have to use the numbers in the table right now. Older than 12, younger than 46. So my first question to somebody is going to be, what numbers do you want me to add together now? Look at your table. It's telling you how many people are between 8 to 12, how many people are between 13 and 17. So what numbers am I going to have to add up here for older than 12 but younger than 46? Help, help, help. Kian, by the way, just a little heads up, Kian, you got a new number, 15, because we had some movement in the class. All right, number 15 now. All right, here we go. Caroline, what numbers should I be adding up according to this chart that are older than 12 but younger than 46?
48.
Yep.
42.
Yep.
27 and 40.
There you go. So my top of my probability fraction is going to be 48, 42 plus 27 plus 40. Good. What, Caroline, I'm going to stick with you on this one because I'm confident in you. What should be my bottom, Caroline? How am I going to figure out what number goes on the bottom?
You have to add all of them.
All of them up. Great job. Great. So I'm going to take 13, 28, 48, 42, 27. And again, you guys can just go to your calculator and do this, but I want to show you step by step where these numbers are coming from. Okay? So that's what this probability is going to be. And I have full confidence everybody in this class can use a calculator, so I'm not even going to ask anybody what you got. On top, you should have ended up with 157 people that are between 12 and 46. And the total number of people that they surveyed was 254. And my rule still applies. If you can reduce it. So if you plug 157 over 254 in your calculator, it won't be able to reduce. So I'm going to leave it 157 over 254. Questions from you guys? So if I see experimental probability, I'm just going to use the numbers in the table. We're all good? Okay, I need to take a break right now. I need to take a quick break and go over something with you because we're about to do a bunch of questions involving the deck of cards. And I have learned the hard way over my, 12 years of teaching this course that people don't play cards anymore. No, nothing like no go fish, no war, nothing like that. Unbelievable, you guys. Maybe some of you studs do a little poker because you roll deep in the cash, but that's not me. All right, I stick with war and go fish with my daughter. So here we go, guys. Let's go over this. Cards, deck of cards. Let's get ourselves familiar with a deck of cards. There's 52 total. You guys can chime in. There's a whole bunch of red cards. And there's a whole bunch of black cards. Anybody know how much? How many? How many reds and blacks there are? Oh, see, nobody plays cards anymore. It's split evenly. There's a hint. It's split evenly.
50.
50?
52.
Yeah, 52 total. I know. Thanks. But and now I'm asking Will, how many black and how many reds? Because there's not 50. What is it?
Well, are you counting the jokers?
This guy. No jokers. There's only one here and I'm talking to him. No jokers.
50.
50?
5 each. Sorry. Jesus.
26, Will.
Oh, okay. Well.
26 each.
Oh, okay.
And of everybody in the class, I'd figure you're a high-stakes poker player, Will, but that's just my opinion.
No, that's just from being with my grandparents.
Okay, hey, that's how I learned too. That's how I learned. Little old maid with grandma. Yep, good times back then. You know how competitive I was? I would have and how ruthless I was to my grandmother. I'd have her make sure she sat in front of the light so I could see through her cards, so I knew where the old maid was, so I would never pick it. That's how ruthless I was. Yeah. All right. The guy wants to win. All right. So anyway, moving on. Red cards. There's 2 suits and a red. Anybody know the 2 suits for red cards? You got to know this. There's 2 different kinds of suits that are red. They would be
Diamonds and hearts.
good. Yes, there's 13 diamonds that are red and 13 hearts that are red. One and only time I draw a heart. There you go. And diamonds. Yes. Black cards. Anybody know the suits in the black cards? 13 what?
Spades.
Yep, spades. And the other ones are called?
Aces.
Aces is a type of card. So there's an ace of diamonds, ace of hearts. Yep.
And then clubs.
Clubs, yeah. There you go. Trees, broccoli, I don't know. I'm sorry. This is why I teach math and I'm not in the art department. Spade, not bad. Arrows, okay. Tomahawk, all right, there you go. But there you go. That's what you need from now. Friday, we need to get a little bit more detailed on what those cards actually are. But for this example we're about to do, 26 red, 26 black. The diamonds and hearts are red, spades and clubs are black. All good? And the total of 52. All right, let's go back now so we can finish this. All right, Jim drew from the standard deck. He replaced the card that shows his results down below. Find here it is again, experimental probability of drawing a heart. So using the data in the table, not an actual deck of cards, using the data in his table, what's the probability he draws a heart out? All right, so here we go. Anna, here you go. How many hearts did he draw?
5.
5 out of how many total cards? You're going to have to add them up quick for me.
25.
5 out of 25, yep. Or 1 out of 5 when I reduce it. Thanks, Ab. So again, 5 hearts out of 25. All right, let's keep going. What's the experimental probability he drew a black card? Now remember what we talked about. Blacks are spades and clubs. Spades and clubs. So using the numbers in the table, what's the probability he drew a black card out? Spades and clubs. 2. My boy, there he is. Isaiah, didn't hear from you yesterday. Here we go. So how many spades and clubs did he draw?
16.
Out of?
25.
Still 25, yeah. And that does not reduce. Everyone's all good. Okay, let's keep moving then. He did it again. Jim did another 25 cards. And this table down below is his results. Combine these results, please. Combine them now. All right, so now we're using both tables. All right, combine the results. Find the experimental probability of drawing a black card now. So use both tables now to find the experimental probability of a black card, because it's no longer 16 out of 25. It's something new because now I have more draws. So black card, spades and clubs. How many now total? 15. Kian, here you go. Spades and clubs, black cards. How many total did he pick?
For the theoretical or for the experimental?
Experimental still, yep. So use your numbers in the table.
Let me add it up.
Yep, go ahead. Both tables, remember.
Yep. Is it 29 out of 50?
29 out of 50. I got something less than 29.
Oh, is it diamonds and spades?
No. Black cards are clubs and spades.
Oh, yeah. I know
Clubs and
something.
spades are the black cards.
It's 27 out of 50.
There you go. And now look, Kian just said out of 50, because now we're combining both out of 50. Any issues so far? Because now I'm going to introduce theoretical. All right, part D. Find the theoretical probability of drawing a black card now. So that means don't use the data from the table. Actually, what are the chances of drawing a black card? What would we expect to draw a black card? So now I got to go back to my deck of cards with you. Theoretical is what should have happened. What do we expect happen if we had a 52 deck of 52, an actual deck of 52 cards? Black card. Here we go, Isaiah. How many black cards are in a deck?
26.
Out of?
52.
There you go. Everyone see now the difference. 26 out of 52, also known as half the deck. Everyone's starting to see the difference when I ask theoretical versus experimental now. All right, experimental probability of drawing a heart with the combined results. So now we're going back. Experimental with the combined results. A heart. A heart. You guys got this. We're rolling today. Dan, here we go. A heart. Add to the combined results.
Out of the combined results, drawing a heart is isn't that 11 out of 50?
11 out of 50. There you go. 11 out of 50. Again, not out of 52 because that would be theoretical. Now I want theoretical. All right. How about in part F, theoretical probability of drawing a heart? Go back to my here. Theoretical probability of drawing a heart, everyone. Not based on the experiment, what should happen. Boom. Here we go. Colin, how many hearts in the deck?
13.
Out of how many in the whole deck?
52.
52. Yep, and that reduces down to 1/4, everyone. 1/4. Okay, everybody all right? Theoretical versus experimental. Any issues we got to discuss? All right, we got one more and we're done. Now, instead of using a table, I want you to use a graph now. All right, and this is all experimental. All right, this is all experimental, so use the numbers on the graph. I'll give you time to get your calculator ready for this one. Spinning a 6. So you guys see, here are the numbers and then the amount of times they were spun. So spinning a 6, according to this graph. Kian, going back to you, how many times was a 6 spun first? How many times did I spin a 6?
7 times.
Yep, 7. And unfortunately, you're going to have to do the hard work for the class. 7.
Yeah, that's what I was doing.
Yep, go ahead. 7 out of, because once you do it, everyone will just piggyback off you for the rest of them.
Is it 7 out of 50?
You got it. 7 out of 50. Good. So it's out of 50 spins. Can't reduce that. Good job, kid. Classmates, thank you. All right, even number, kids. Even number. According to my chart, even number spin. Ooh, ones. Liz, good morning.
Is it 24 out of 50?
24 out of 50. You got it. And then you guys go to your calculator. That should reduce down to 12 out of 25. Thanks, Liz. Good work. Not spinning a 1 in part C. I'm not going to spin a 1. 1-4. Eliana, good morning. Not spinning a 1.
That would be 42 out of 50.
Darn right. You guys are on fire today. 42 out of 50. What did I have? That reduces down to 21 out of 25. Just make sure we always have both because you guys saw yesterday, multiple choice answer. Usually they're all reduced. Spinning a number less than 3. Spinning a number less than 3. 3. There we go. Hello, Anna.
Hi.
Hi.
It's 14 out of 50.
Darn right it is. I cannot stump you guys. Also known as 7 out of 25. Come on, 2 more. We're 4 for 4 here. Spin a 1 or a 3. Spin a 1 or a 3. What are your chances based on the table? 11. Here we go. Liz, back to you. You got this. Spinning a 1 or a 3.
17 out of 50.
Yep. 17 out of 50. Now, hey, before I get to the last one, that 17 out of 50 is the experimental. If I ask for and I just wanted to show this to you to compare. If I ask for the theoretical probability of spinning a 1 or a 3, it would be 2 out of 6 because there's a 1 and a 3, 2 choices out of 6 total. All right, everyone see the difference now. And then finally spinning a 7. Oh, boy. Who am I going to get on this one? Kian, I'm not going to get you. Finish it. What do you got?
Impossible.
Correct. So what's the probability for an impossible event?
0 out of 50.
Yep.
We're good.
Big goose egg. Impossible. All right. Any questions from you guys? All right. You guys know I'm not going to hold you any longer here. Perfect. Look at that. 20 minutes. Done. You guys will have the next section for the assignment tomorrow. All right, guys. Have a good one. Take care, guys. Good seeing you. Good session today.
Have a good one.
You too, boss. Behave.
Thank you.